Acunetics helps thousands of organizations secure their websites and web applications across the globe. Whether you're a one-person team ensuring the security of a few websites or a large organization interested in automating your web vulnerability assessment and management, Acunetics is here to help.
Hi, and thank you for watching the WAFs. We don't need no stinking WAFs presentation here at the OWASP conference. Before we begin, let me give you a brief background of what I do and where I work. I'm a senior application security architect working at PointClickCare, which is a world-class software organization that primarily focuses on the long-term post-acute care, the senior care, and the home care markets. Essentially, what we do is we make sure that your grandparents, or your parents, depending on how old you are very well taken care of. I'd also like to say that it's an honor working at PointClickCare, because for every hour and every day's work that I put in, it really affects millions of lives of seniors in many countries, and it's a very fulfilling career. So let's begin. First, I want to talk about web application firewalls. I'll give you a brief history. Now, WAFs, or web application firewalls, were originally created in the early 90s as network firewall extensions by Gene Spafford, Bill Cheswick, and Mark Ranum. But they can only handle a very few applications like FTP or RSH. Here you'll see in the picture, a request comes into the firewall. The firewall detects a threat. It returns a 403, forbidden. Or if everything is fine with the request packet coming in, it validates it to the application, and the application is deemed secure. Now, dedicated web application firewalls, they entered the market later in the decade. Aaron Reshef and Gilly Rannan were the inventors of the first dedicated WAF, the AppShield. But here again, we see the firewall taking a request and rejecting or forbidding if it doesn't pass its rules. But now you see a separate entity. It's called a web application firewall. So the request gets proxied to that. It then inspects all the data coming in. If there is an error occur, it returns a 403 or forbidden. If not, it sends the request to the application that's now secured. So the top 10 web application hacking techniques laid the foundation for the WAF market. These will look very familiar. Hidden field manipulation, cookie poisoning, parameter tampering, buffer overflow, cross-site scripting, and many more. Now in late 2002, that's when the open source project Mod Security was introduced, which is heavily used in the market today. So what is the purpose of a WAF? Well, in short, it is to block malicious bidirectional web-based traffic. It's not an ultimate security solution meant to work. It is not an ultimate security solution meant to work with other network perimeter security solutions. When used alongside network firewalls and intrusion prevention systems, WAFs provide a holistic defense strategy, as you can see in the picture below. So what are some of the problems that we have with WAFs? Well, WAF rules and policies can be overly broad. This leads to many false positives, which leads to whitelisting URIs or headers or cookies or parameters. You either disable rules to allow the applications to work as they were designed, or you add custom rules to limit the exposure. And why does this happen? Well, because the WAFs, they can't be sure how your application works on its own. Some interesting information, an article I've read approximately a month ago. It said that 40% of security professionals say that half of cyber attacks bypass their WAFs. Wow, that's a big number. Additionally, from the web, here is a listing from Azure's website. It talks about WAF exclusion lists. You can exclude URIs, headers, parameters, cookies, and the like. And even the wording below states that, certain Active Directory applications, they insert tokens with special characters that could be blocked by the WAF itself, so you can exclude them. Additionally, you can even remove certain rule sets from running themselves. Why would you do this? Because if you need to have your application actually be running, and the WAF that you just implemented is blocking that particular page, you might be desperate, and you might actually disable whole rule sets completely. This is a horrible thing to do. So why do these problems arise? Well, WAFs, they don't actually know how your application works. Here in the picture below, you see how the WAF takes in a request. It any validated request, it processes the application, deemed safe. But if you have any whitelist or disabled rules or custom rules, you really are bypassing the WAF itself. And everyone knows once a bypass is established, that hole is very hard to close in the future. Have you ever tried to Google bypass WAF? You'll see lots of websites and cheat sheets and Git repos. OWASP itself even has a SQLi bypassing guide that'll help you bypass your WAFs. Have you considered these? We're all familiar with the JavaScript colon syntax to run JavaScript inline on a web page. But take a look at the very next line, Java &foo, right? You see that that's exactly the same thing. You're actually allowed to embed characters into the JavaScript keyword. Or how about the next one? That's the expression tag. That you can embed comments within every letter of the word. How about the very last one? This product is, well, it rhymes with JS duck. Let's call it that. There is no textual characters. It's all spaces and non-alphanumeric characters. Does your WAF block these? Generic rules are extremely difficult to create and maintain, so you always need to validate and sanitize untrusted data. Now we're going to introduce you a new concept of SAN-WAF. It's an application level security control. What it is, it's a sanitation web application filter. And it's implemented as a filter or intercepted. And it's added to increase your application security. It's application specific. It executes prior to any application code being executed. It pre-validates parameters before passing them to the application. It works in line with your application. It addresses whitelisted WAF rules, URIs, cookies, headers, and parameters. And it really validates untrusted data entering into your application, which is one of the biggest security issues, is trusting untrusted data. How many times have we seen where data that's entered in by a user gets echoed out? Hence, you have a cross-site scripting vulnerability introduced. So what is the purpose of SAN-WAF? Well, it's to provide a generic application-centric mechanism to sanitize all untrusted data entering applications. Here in the picture, anything that comes prior to the SAN-WAF is deemed insecure. The SAN-WAF itself, it will forbid data from entering the application, or it will proxy into the application itself after the data has been sanitized, making your application secure. Now let's take a look at the bypass example. Let's say you have a cookie that's being blocked by the WAF, and it's causing you an issue. So you decide to whitelist it. Does this decision create a vulnerability? So here a request comes into a firewall, passes the firewall rules, it'll get proxied to the WAF. The WAF itself, well, if the request is valid and passes its rules, it's still green, everything looks good. However, since we actually whitelisted a cookie, what are we doing? We've introduced unvalidated data into our application, which turns your application red. With the introduction of SAN-WAF, which would then inspect, you can configure it to inspect that cookie and make sure it is valid, it will turn your application back to green again, making it secure. Now, it's got to be understood that SAN-WAFs do not replace WAFs, like WAFs never replaced firewalls. They are an additional layer of protection. They can be implemented as a filter or interceptor. In the session themselves, they don't have to be validated prior to the SAN-WAF interrogation. It really stops all invalid requests to the applications. So this reduces your compute time, especially if you're not inspecting those sessions. It's extremely fast in operation, very low overhead. It's simple to implement and configure. And really, it focuses on data sanitation. Now, who hasn't seen this code? Well, Java developers anyway. We've probably written this code thousands, if not tens of thousands of times, where you read a request parameter into a string called S. And then you inspect that. You say if it's not null and the length's within a range of 0 to 10, And then you have some more code in there. This is writing sanitation code, and it's very tedious and time consuming, which leads to it being error prone. Thus, your data is not really fully sanitized. Wouldn't it be better to pre-validate or sanitize your parameters before using them in your system? Let's take a look at how SANWAF works. This is at a 50,000 foot level. So it's a logical view from the browser to Tomcat to the application. So the browser submits some payload. Let's assume there's an evil payload into the application. The application will then call the SANWAF is threat detected, passing in the request object. SANWAF will process the parameters. It will look for errors, and any errors that it sees, it will compile them, and it would set the error attributes onto the request object, and then return a pass or fail to whoever called it. Then it's up to the application to get these error attributes, right? If it's a fail, that is. If it's a pass, if it's a fail, then it gets the error attributes, and it's up to you what you want to do. You can throw an exception, a security exception, and allow an unhandled exception handler to handle it and to nicely present the data to the end user. But it's really up to you how you want to progress from there. Here's the structure of SANWAF. It has global settings, and it has these things called shields. We'll talk about them in just a bit. The shields themselves have shield settings, regex settings, and metadata settings. Now, let's first talk about the global settings. There's a master enable disabled flag. Well, this is kind of easy to figure out what that means, what it does. It turns it on or off. It also includes app version information. Now, this is useful because every time you have an error and it gets logged, you might want to include this app version. So for posterity or for inspecting what's occurring in your application, you know exactly what application version this error occurred in. It also defines error handling, how you want to handle it. Do you actually want a tracking ID to be correlated with this log entry? Do you want it to return the list of elements? Remember in that flowchart before when it said it sets these request error attributes? It's up to you. You might not want them. You just want to say it's a pass fail. That's fine. You don't have to have it. That's what you configure here. Next is generic error messages. These are default error messages for SANWAF data types, which will be explained shortly. Now, shield settings. Well, what are shields? Shields are really logical units to group your rules. You don't have to have many shields, but you have to have at least one shield. It's up to you. You can have one shield and put all your rules into it, or you can logically group your rules into multiple shields. Now, these shield settings include the name of the shield, right? So that you can understand which shield actually caught the error if you have more than one configured. A maximum min data length before processing. This is useful because let's assume you have a shield configured for examining cross-site scripting. And you can't do a cross-site scripting exploit under 4 characters. So if you specify the minimum to be 4 characters in data length, this shield won't even fire, saving you processing time. It has specific error messages for SANWAF data types. These actually override the custom error message, the global error messages, that is. And you can specify them for each individual shield that you have configured. Next, you have regex and metadata settings, which we'll get into right now. So for the regex settings, it has a minimum length for the regex to fire. Again, everything we do in SANWAF is got to be performant, because if you're going to inspect every single parameter, you got to make sure it fires very, very, very quickly. So the minimum length's there to set. So why even bother run the regex unless it meets a certain condition? You have a force regex settings, which includes exclusions. We'll talk about that more in detail in a little bit. We have auto run patterns, and this defines what all your string typed elements have to go through. You have custom regex patterns to secure specific parameters, headers, and cookies. Some of the metadata settings, well, you have enabling sections. That is, perhaps you might want to have a shield that only looks at request parameters. So you'd only enable the parameter sections, not the headers or the cookies. Next, you have section case sensitivity. Well, with this one, you could specify whether you want to, when you're requesting the parameters, to look at them in a case insensitive or case sensitive way. In a previous job, not where I am now, but a previous job, we had, I remember one page it was written. We had a variable, let's just call it foobar. And in the page it was read 3 different times, and they all went to the same variable. One was a foobar with a capital F, next was foobar with capital F and capital B, and next was all lowercase. They knew one of them was there, but different developers were passing in different cases. This is terrible, I know, but that's what this is for, is to address that issue. Next, it has 3 lists, security lists. And these are for parameters, headers, and cookies. And this is where you define which parameters, headers, and cookies are actually going to be protected by SAN-WAF. So now let's talk about the SAN-WAF data types. There are 9 of them in total, and they're very powerful. And a lot of them are written to be very fast. First is the character. I think that one's self-explanatory. It's a single digit, single character, anything you want. Notice it doesn't have a max min setting. Then next is the number, which could be any positive or negative number, right? There's no limit to the length or the size of the number itself. Now notice here, we can specify the max and the min. This determines the length, right, of the string that's coming in. So if you know that your number, assuming it's a positive only number with no decimal, has to be 2 characters long from 0 to 10, you can say minimum is 1 character, maximum is 2 characters, and that'll limit it. So if somebody or a hacker tries to actually send you a lot more data, it won't even be looked at. It will be rejected just by the length setting. Next is a delimited list of numbers. What this means is, you could take a look at the example, 1, 2, 3, comma, 4, 5, 6, is that you're expecting this parameter, header, or cookie to actually be a list, but it's delimited by some character, in this case, a comma. Next is alphanumeric. That's all the alphabetic and numeric characters that are allowed. Next is alphanumeric and whitelisted characters. This is a very powerful, very, very powerful data type. In our example, you see O'Brien, very common. It's alphanumeric, well, not numeric, but it's alpha anyway, but it has a special character, the single quote apostrophe. So this allows you to increase the scope of what alphanumeric and the whitelisted characters represent. Next is the string, the S for string. And this uses the shield's auto-run regexes that are generated. Next is constant, which is a list of constants to match. This is very useful. For instance, let's say you have a form and you're going to ask for what is the user sex, either male or female or other. You can have 3 different values specified. So if it's not one of those 3 constant values coming in, it will be rejected at that point. Next, we have custom regexes. And these are ones that you define specifically for parameter. So they're not like the string one, which uses the auto run regexes defined with the shield. This one is for specific parameters, and it can be used by many parameters. You could use date as an example, right? And apply them to all your date fields coming in. And finally, we have a Java class method. And here is where you're actually able to run a Java method for a particular parameter. Very powerful. You could do whatever you want. You connect to databases. You could do anything that you want. Now, so how does SAN-WAF actually work here? So when a request is processed by SAN-WAF, remember it has multiple shields. If you only have one, for loops is a simple loop. It loops through for each shield. And inspects, is the header, cookie, or parameter, let's call that a key. Is it within the shield's minimum and maximum range? If it is, keep going. Otherwise, bail out. Is the key protected by the shield itself? That is it part of the secured parameters, either parameter listing, cookies, or headers? Next, for each value, that is, well, if the key is a value, for each array value of that key, right? Does the key's value match the max and the min range setting pass of the shield? Yes? Well, look up the key data type. And then let's call the is threat detected for the key value. And here, notice the string is not listed on here. We're going to talk about that in the very next slide because it's a more complex behavior. Then let's assuming a threat was detected. It says, is error handling enabled? Well, if it is, it adds the attribute to the request object, the tracking ID in the error JSON, and then it returns true. Now let's take a look at strings. We'll start off where the is threat detected occurred. And again, this is just for strings. We look at the data type, going to be string. If no data type is found, interesting. So this isn't a non-secured parameter cookie or header. It says, is the regex always enabled for this shield? If it is, it checks. Are you not part of the excluded list? So if you're not excluded, run all the auto run regexes configured in the shield and return pass fail. However, if it is the string data type, well, it knows just run all the auto run regexes and return or pass or fail. So it's really quite simple. So what's the performance of all the SandWAF data types? Well, it was written to be very, very highly performant. Now, obviously, the quickest ones are going to be character, number delimited, alphanumeric and more characters, and the constants. They are by far the quickest of all the data types out there. We fail very, very, very fast. So let's say you have a number coming in, and the very first character is an A. It fails on that. It doesn't look at any other character. So it doesn't have to, it's written to fail fast. Now, string performance, well, it really depends on the auto-run regexes created and specified. So if you have one that's very quick, it's going to be quick. Now, remember that SandWAF will actually compile and cache all the regexes upon startup. This also impacts the regex data type. They are also, the performance will be dependent on the regex itself, but they are also compiled and they are cached at startup. So it's only done once to compile. So they are quite quick. And finally, it's listed as the Java method. The performance depends on the complexity of the code. If you're hitting up a database, that's going to be a lot slower than if you just use standard code. So the way Java methods work is that it uses reflection, but we instantiate and we cache the class method at startup. So this is done once. So the performance of really running a Java data type, SandWAF data type, is that of you running a static method. So it's still very quick, but again, will not be as fast as the above ones listed. So let's take an example here of how do we actually use this in SandWAF. So in this example, we're talking about a delimited set of numbers. So we're going to have a parameter array, which is called parm array, and just a regular parameter called delim. And it's going to contain a comma delimited set of numbers that must be all 5 digits in length. So here in the shields metadata secured parameter section, we have 2 items. The first item being the parm array, specified with the n, curly braces, comma, and curly braces, bracket, 5, comma 5, and bracket. So that's a numeric, comma delimited numeric that has to be 5 characters long. And we also have the item delim equals n comma, the exact same thing. You can also specify, this is the exact same configuration as we saw before. You can specify it in one line. So for instance, you say that I want to have all my 5-digit comma delimited numbers in one parameter item entry. You use 3 colons to separate them. So here in this example, you have 2 parameters defined within one item entry. You can have as many as you want. And it's a nice way to keep, for instance, all your dates together in one simple line. So you don't have to keep looking for them as people add it. So they add it to the date item. Let's take well, before we take another example, let's take a look here that all headers, cookies, and parameters, they can be array notated. We use the star character right, as a placeholder. And as an example, we have P star. So parameters of P1, 2, 3, 4, and on, they're accepted. But all these have to be numeric. Here are some more examples. You can use it in square brackets. You can have dots before, or you can have the complexity increases. There really is no bounds. You can be square brackets, regular parentheses, and so on. It's up to you. So you can experiment as you like. It's very, very easy to use. Let's take another example here of a delimited set of numbers, but this time let's use a regex. This time, let's also use a cookie called cookie numbers, and it contains a common delimited set of numbers that must all be 5 digits in length. So here you see the shield and a new entry that we haven't seen before, regex, with its custom parameters. And in there, there's an item, which has got a key that says delimited set of numbers and a value. So that would be a regex associated with that delimited set of numbers. Next, we have metadata secured, but this time instead of parameters, we see cookies because we're addressing a cookie now. And the item name of the cookie name would be cookie numbers. And its data type is R, curly bracket, delimited set of numbers, 5, 5. Now, why is it important to add 5, 5? Well, let's assume you don't, and your regex defined above, it doesn't deal with the length either. This is a great way to have a regex DOS, denial of service, because somebody could pass in a cookie number that's 1,000 characters long. And if your regex is quite complex, that takes a lot of processing, a lot of compute time. On this case, if you say it has to be 5 or 0 to 5, however you want to specify it, you're actually pre-validating the length of the data before it actually hits the regex, right? But it also should be noted that this example is an unrealistic example because using the n, right, the number, the n curly bracket comma is much quicker than using a regex. Let's take another example, an alphanumeric and a whitelisted character. So here we're going to use a header, right? And the header name is going to be alpha, comma, colon. That supports all alphanumeric characters, including the comma and the colon characters. So same what we see before, shield, metadata secured, but this time it's in the headers that has an item with an A, curly bracket, comma, colon, and curly bracket. That's how you specify a header with the name as an alphanumeric and more. Finally, let's take a look at using a Java class. Well, first thing you have to do is you have to create a class that has a public static Boolean method that takes in one parameter. Right now, the Java class only takes the value of the parameter that you've defined it for, or that you set that particular data type to. In this is an unrealistic scenario, I know, but here's a package com.foo, and the class is called bar. And the method, again, is public static Boolean greater than 10 with a string, one string called v. And we check if the integer to parse int is greater than 10, return true, else false. Now, the way you configure this in this shield, the shield's metadata secured parameters, and this time, you say that the item, so this particular parameter name, unit test Java, it's going to be protected by this particular fully pathed class.method name. Very simple to do. Next, we're going to look at string and regexes. So here you see an empty listing on the page that has a shield and a regex section as well as a metadata section. I've mentioned this before, but I want to reiterate again because it's quite important. We have this concept of in regex of auto run patterns. These are the patterns that you want every string, every parameter, cookie, or header that has the data type of string to run. Here you see I've set up a string called string parameter equals s. So that string parameter equals s. Notice it doesn't need to specify the key name because here it's going to be using its data type of string. So it's going to run all the auto run parameters listed. On the other scenario, if you just want to set up a regex for one specific parameter, so here's a delimited set of numbers that we've seen before again, that's where you use the R, the data type, the regex data type. So that's what the difference is between a string and a regex. One is assumed to always be running it, and one is assumed to not always be running it, right? And the reason why this is done is because remember that force regex? You might want to set up a shield that's always looking for SQLi, and you don't care what the parameter is, inspect it for SQLi. So how do we implement the SAN WAF? Unfortunately, only Java projects are currently supported. If you want to create another open source project in your own language, please contact me. I'd love it. This currently SAN WAF is zero dependencies. Well, I'm not sure I should call it zero dependencies, but it really has no runtime dependencies other than the JRE and the Tomcat servlet. And the reason we don't even have any loggers defined in SAN WAF. The way we do that is we implement it. You have to implement an interface and pass in that class to us, and whatever logger you want to use, an SLF for J, log for J, and so on, it can be used without incorporating any dependencies. Now, we feel this is important because it makes it very simple for you to consume SAN WAF in your application. It can then be implemented as an application filter or an interceptor. You can use SAN WAF methods independently or in the application code. Here is an example of implementing a SAN WAF filter. So you create a SAN WAF filter to validate all incoming requests, right? So you see public class SAN WAF filter implements filter. And then you add it to the filter chain. Well, it's done, right? But make sure you call the filter chain.do filter at the very end. And notice the white text below. Static SAN WAF equals new SAN WAF, right? Then in the method, it says, in the do filter method, if SAN WAF.is threat detected, passing in the request. If it is, well, it's really up to you what you want to do, as mentioned before. If you want to get the data, you call SAN WAF, you call SAN WAF.get error messages, passing in the request object, and it'll give it to you in the JSON format, which we'll see an example very shortly. But it's really up to you how you want to process when a threat's detected. Quick mention about logging here. If you don't provide a logger, the system.out.println will be used for logging. This is terrible. So the way you do this is you create a class that implements a com.sanwaf.log.logger interface. And there's only two, error and info, that are provided. And there you could set up your own loggers that you want. SLF for J, log for J, as I mentioned before. It's up to you. Now we do this in order to not add any more dependencies than we have to, which is essentially it's next to none. Then when you instantiate SAN WAF, you pass in the logger, right? So here SAN WAF equals new SAN WAF with a new SAN WAF logger. Very simple. So please do not ever instantiate SAN WAF unless you're doing it for test without passing the logger, because we all know system.out.println is not fast. It will not be as performant as you probably need. Let's take a look at an example of an error message and how it's presented by SAN WAF. In this example, we have a parameter defined as alphanumeric and more parameter, right, which allows spaces and question marks. And here's some payload, some bad data, blah, blah, blah. When you call the get tracking ID, if you've enabled tracking ID, that is, in the shield setting, it will pass in the tracking ID. This is very useful because if a customer sees an error repeatedly, they can give you a tracking ID and you can see exactly what's occurring and help them get past that block. Next, you have an example of what get errors would return. This is an exploded JSON view of what would happen, but typically it's on a single line. So you can actually configure your SIM to monitor your log files looking for this. And if they repeatedly see the same thing occurring, you can raise further alerts and have your security team investigate further. What I want to point out here are the sample points. Because notice how we tell you what parameter, the data that's occurring, that's going to be escaped, obviously. What error, we give you the error message. This error message, these are what's either configured in the global settings or in the shield settings. It tells you what data type that caused it in English text, in English terms, the shield's name that occurred, as well as the app version where this error occurred. And the reason why you do this is, notice how the sample points over here, they mark up with the data. Look at below, right? I only put the numbers so you understand the positions, that the exclamation, the semicolon, and the 4 dashes are in error. Now, you can actually take that data, that JSON, and then even in JavaScript, you can specify it to the end user, come up with a nicer screen. Not that this is a nice screen by any means, but you could come up with a nicer screen and prevent a nice message to the end user saying, in this case, invalid data submitted, please contact and please correct and resubmit. Well, the alphanumeric characters and spaces and question mark are permitted. Show the bad data, you can even highlight it in this case, give them a back button to help them out so they don't have to rekey on all the information. And again, there's that tracking ID with the 1.2.3, which would be the application version. It's up to you how you want to render this data to the end user, or if you want to at all. Now, SandWAF, if you download the application, you'll notice you also get a sample. Well, I can't really call it an application, but it's a servlet, right? And this SandWAF servlet, it gives you a simple page. It's a very rudimentary servlet. All the HTML is hard coded and so on, but it allows you to play and test with it. So you could put in valid data. And as you can see, the SandWAF results with the error ID and the error JSON listed below. So it's very useful for you to play with. And then you can even add your own and maybe try to make these error messages look better before you present them to the end user. So where do you get SandWAF? Well, you guessed it, in GitHub. So you go to https://github.com/Bernardo1024/SandWAF. And there on the right, you'll see this is what the code looks like. It's very tight code. It's very small, 0 dependencies. Well, not really 0, but mostly 0 dependencies. And in here, you notice how there's no bugs or vulnerabilities. This is a Jacoco scan represented in Sonar, in a Sonar report. The 2 code smells are really related to that logger.systemout, right? That one that if you don't instantiate SandWAF with your own logger, it will use the system out one. That's what those are for. So I can't get rid of those, unfortunately. So thank you for watching my presentation, and I hope that you'll incorporate SandWAF into one of your projects. If you want to contact me, please email me at bernardo.toronto@owasp.org. But before I sign off, I'd like to give special thanks to my wife and family for putting up with my late nights of coding SandWAF. I'd also like to thank Point Click Care, especially my boss, Andrew Daters, for encouraging me to open source the SandWAF software. And finally, I want to thank Tabitha Lama, a colleague and a good friend of mine, for helping me with this presentation. So now I'm leaving you with my collection of deflated balloon animals. I hope you enjoy them and have a great day. Thank you. Bye-bye.